When in Doubt was first released because of changes in the regulations resulting from recommendations of the Commission of Inquiry into the accident at Dryden, Ontario. If you are one of the many who have seen the first version, the changes to this video may not be obvious, but the information is more current. This enhanced video, along with a revised companion booklet, has been re-released to provide the latest information on de-icing and to highlight the cold soaking phenomenon and the more widespread use of type 2 anti-icing fluids. Remember, there is no such thing as a little ice. In airline operations, where large numbers of aircraft are dispatched, the process of assuring that each flight will be safe must be a team effort. In smaller commercial and in private operations, the pilot may have to perform all of the functions. In all cases, the pilot in command is ultimately responsible for ensuring that the aircraft is in a condition for safe flight. If the pilot cannot confirm that the aircraft's critical surfaces are free of contamination, takeoff must not be attempted. This is a simulation of the takeoff of a 727 with a weight of 146,000 pounds. It is snowing lightly. With checklists complete, this flight begins its takeoff roll.
Doesn't look good. No, it's tough. We don't have much runway left anyways. There she goes. Watch it.
Too low, flat.
Easy does.
Too low, flat.
A contributing cause of this crash was aircraft and engine icing. Let's review aircraft icing just once more to help everyone continue to make informed decisions. Wings lose efficiency when they're contaminated. That means frost, ice, snow, slush, freezing rain, anything on the outside of the aircraft that should not be there. Even slight amounts of contamination on the leading edges and upper surfaces of the wings and tail result in substantial degradation of lift and an increase in drag. In flight situations, that also means all your stall warning systems, like the stick shaker or the horn, can't warn you about an impending stall. They're calibrated to work as an effective warning under clean wing conditions only. There is no such thing as a little ice. Ice is dangerous in any quantity on any part of your aircraft. On takeoff, the ice on this wing may shake off and be sucked into this engine. It will probably happen just as you rotate on a slush-covered runway in bad weather. That's why we need the clean aircraft concept as the only way to fly safely. The clean aircraft concept means no contamination adhering to the critical surfaces of your aircraft, no matter what the weather. There are 13 major factors that contribute to contamination. Ambient temperature. This gives you a good indication about the potential for icing conditions. Aircraft surface temperature. It is a more reliable indication of your susceptibility to icing, especially when you have a short turnaround time at a station. Precipitation type. Dry snow tends not to stick to the aircraft as much as wet snow, while freezing rain, combined with any snow, gives you slush. Precipitation rate. How heavy is the rate? Is this a full-fledged blizzard or just a light snowfall? Relative humidity. Combined with air temperature and surface temperature, You can have icing conditions even though it's a clear day. Solar radiation. Is it a bright, sunny winter day, or is it 100% overcast? Your aircraft will have a warmer surface temperature on some clear sunny days and a lower surface temperature in shade. Wind speed and direction. In Canada, north winds are usually cold and dry, while southerly winds are usually warmer and moist. Aside from being a factor in your takeoff performance, winds can blow contamination onto or off of your aircraft. Operation in close proximity to other aircraft or structures. The terminal building usually acts as a windbreak, but that causes wind eddies on the leeward side. That increases the apparent amount of snow that is falling. Jet exhaust from other aircraft can often blow snow, ice, or slush back onto your aircraft, or cause snow on your aircraft to melt and refreeze as ice. Operation in snow, slush, or wet surfaces. Since most aircraft don't have fenders, you'll be kicking up slush or water from the landing gear on the apron, taxiways, and runway. Taxiing with flaps down increases the likelihood you'll splash contamination on the flaps. Will it stick to the aircraft? It depends on the air temperature, surface temperature, relative humidity, and more. Aircraft component inclination angle, contour, and surface roughness. Every aircraft is different, but generally aircraft collect snow, freezing rain, and slush in all kinds of nooks and crannies. Smoother designs don't collect as much contamination, but they're just as treacherous because the smooth surface looks wet rather than icy. Presence of de-icing anti-icing fluid. De-icing anti-icing fluids provide a measure of holdover depending on a number of factors including temperature, precipitation, humidity, solar radiation, and wind direction. Strength of de-icing anti-icing fluid. Again, there are more variables. Some airlines or contractors buy pre-mixed solutions. Others mix right at the nozzle. There are a number of mixtures available containing ethylene glycol, propylene glycol, corrosion inhibitors, and water at various temperatures and percentages. Fluid application procedures. Again, more variables, based on all the previous variables, plus any specific requirements of your operations manual and the aircraft manufacturer. Some of the variables are obvious. If it's cold and snowing, you have contamination conditions. But others, like cold soaking, are not so obvious. For example, the air temperature is 14 degrees Celsius. The aircraft skin is 4 degrees. This aircraft just arrived from an extended flight at 24,000 feet, where the air temperature was minus 34 degrees. The fuel, which is still close to minus 34, is cold soaking the wing. On a cool day, this wing will turn precipitation into ice, or humid air into frost. This frost can form on both the upper and lower surfaces. This wing section shows that where fuel tanks are located in the wings, the temperature of the fuel greatly affects the temperature of the wing surface above and below these tanks. Note that ice can form in precipitation even when the ambient air temperature and the wing surface temperature outside the fuel tank area are above 0 degrees Celsius. To avoid these problems, some airlines use warm ground fuel whenever possible. Some carriers even instruct their pilots to shift fuel from the wing to center tanks and have the warmer ground fuel loaded in the wing tanks. The clean aircraft concept starts here. If the conditions that promote icing are present, you have to be alert before you get to the apron. When in doubt, ask. Ask the weather office for the most up-to-date forecasts. Find out what kind of temperatures and precipitation you'll experience on your route and on the apron at all your stops. Check your flight manuals for the manufacturer's recommendations and your operations manual for the standards your airline has. And consult with the rest of your team. The pre-flight meeting is the best time to bring everyone up to speed. Cabin crew are part of the team too. They're professionals and can see parts of the aircraft you can't see from the cockpit, and they need to know that you'll listen to them if something doesn't look right. If you're taking over an aircraft on a quick turnaround, let the in-charge flight attendant know you expect to hear about any observed contamination, and have the in-charge pass the word along to the rest of the cabin crew. The apron is the place to use the best testing equipment available, your eyes and your hands. As part of your walk-around, look carefully for any contamination. When in doubt, feel. With smaller, low-wing passenger aircraft, it's fairly easy to check for contamination. For large aircraft, it's almost impossible for you to check the upper surfaces closely. That's where your ground crew comes into the picture. Your ground crew supervisor is in a better position to observe and report contamination on the upper surfaces. When in doubt, ask. Be especially careful if you're taking over from another crew, or if your aircraft has been out overnight. Applying de-icing anti-icing fluid is one of the most common ways to follow the clean aircraft concept. De-icing fluid is a mixture of hot water and glycol sprayed on the aircraft to melt and flush off contamination. There are more variables to de-icing than there are aircraft flying. So how can you be sure your aircraft is being de-iced properly? When in doubt, ask. Ask your apron supervisor about de-icing. Check your operations and flight manuals for recommended procedures, and use the aircraft anti-ice systems appropriate for conditions. Remember too, you may have to factor some anti-ice effects into your takeoff speed calculations. On the apron, check again. Has the weather changed? The holdover time of de-icing fluid varies widely, depending on factors as simple as wind speed. Your de-icer is knowledgeable about most aircraft, but make sure. Check your flight manual for specific areas to avoid during de-icing and anti-icing, and communicate that information to your ground handlers. Some manufacturers recommend specific control surface settings for de-icing. Check your manuals for complete details. Remember, if you change any of your pre-takeoff settings for de-icing, anti-icing purposes, put them back in the pre-takeoff configuration. The fuselage should be de-iced and anti-iced from the top down. Ensure that wings, stabilizer, and elevator surfaces are de-iced and anti-iced equally and symmetrically. Some areas to avoid are directly into engines, APUs, pitot tubes, static ports, and antenna arrays. Again, consult your operations manual for complete details. Ground and air traffic control are part of the team too. They appreciate the problems associated with winter operations and will do everything they can to expedite your departure. Type 2 fluid is a thickened anti-icing fluid that is applied to prevent contamination from sticking to the aircraft. It should be used on aircraft with a rotation speed above 100 knots. The fluid is designed to shear and flow off the aircraft during the takeoff roll. Check your flight manual and ops manual, and check with your maintenance supervisor for their recommendations on Type 2 anti-icing fluid. The areas that are visible from the cockpit are normally de-iced or anti-iced first, so that during the pre-takeoff check, the pilot may be assured that other areas of the aircraft are clean. Areas de-iced or anti-iced first will generally freeze first. Make a note of the time when you start the final application of de-icing or anti-icing fluid. And if your company has recommended maximum times for holdover, keep track of your time. When taxiing, especially if you have a delay reaching your runway, keep an eye on the time and an eye on your aircraft. When in doubt, get help. Have someone take a look. Icing conditions often mean slushy or snowy taxiways. By keeping your taxi speed down, you reduce the possibility of splashing contamination on your aircraft. Don't follow too closely behind another aircraft, as the exhaust or prop wash will blow contamination back on you. Keep watch on other aircraft. They're in the same situation you are. You can see parts of their aircraft they can't. If you see something, tell them.
looks like there's some snow on the right wing. It's sticking a bit.
I'll go back.
The decision-making process is a complicated one. You have to recognize the factors and stresses you'll encounter. Weather? Below freezing with snow and blowing snow. Low ceiling with more snow along the route and at the next destination. Aircraft? Extensive anti-ice systems, but near max weight. No snags, but a sizable takeoff run. De-icing? Done at the apron. Holdover is probably good for another 5 or 6 minutes. Crew? Experienced. Contamination? Some observed snow on one wing, some blowing around loose.
Weather, not great, but I've flown in worse. Aircraft? Lots of power, but we're on the heavy side today with a bit of slush on the runway, and it's only 8,600 feet with a poor overrun. Schedule? Late by 5 minutes now, so connecting passengers might not make their flights. If we go back and de-ice, we'll be further behind schedule. We might lose our arrival time in Toronto. Dispatch will be annoyed that we pulled out of line, and there's another pile of money for de-icing. Stress, schedule, budget, to heck with all that, life's too short. Contamination? I can see this stuff. Well, when in doubt. Tell the tower we're going back. We've been in line too long. We'll taxi it back, then call operations and see if they can de-ice us as quickly as possible. Good to see you, Captain. Your wings were iced up again. We cleaned both wings and we inspected everything again. You're now clean.
Making the right decision is your responsibility. Your team in the cockpit, in the cabin, on the apron, and in the office will give you the best information they can. But the final decision is up to you.